All right, good morning. Today we're going to talk about Bronsted-Lowry conjugate acids and conjugate bases. Conjugate acids and conjugate bases only apply to the Bronsted-Lowry theory of acids and bases, or you say the Bronsted-Lowry model of acids and bases. Remember, Arrhenius acids start with a hydrogen and have to be able to produce a hydrogen, and an Arrhenius base is going to end with an OH, a hydroxide group, and be able to produce a hydroxide group when you add them to water. The conjugate acid, conjugate bases that go with the Bronsted-Lowry theory are totally different. It only depends on what's happening with the hydrogen. And if you remember, take a look in your notes, that a Bronsted-Lowry acid has to donate a hydrogen, and a Bronsted-Lowry base has to accept a hydrogen. So we're just going to focus on the movement of hydrogen. So if you take a look at what we have here, first off, let's just kind of nail a couple things down. To the left of the yields arrow, remember those are the reactants. And on the reactant side, you'll find either the conjugate acid, you'll find the acid and the base, or the base and the acid. The conjugates will never be on this side. On this side of the equation, the product side, is where you'll find the conjugates, either the conjugate acid and the conjugate base, or the conjugate base and the conjugate acid. You'll never find the acid and the base on this side. Just the conjugates over here, and the acid or the base over here. They're never intermixed, okay? So just first of all, remember that, and that'll cut down probably about 50% of the problems. The first thing that I usually do when I'm trying to figure out the conjugate acid-base pairs is that I look and see, start off on the reactant side, and I try to pair them up, okay? I try to see like, hey, which two are most similar from the reactant side and the product side. So if I first take a look at it, HCl is most similar to Cl minus. If I were to compare HCl to H3O plus, that doesn't really make any sense. So right off the bat, I know that these two go together. So I just kind of group them together. All right. So that's the first step. Step number one is to group them together, and then just double check yourself. H2O, is it possible that it become H3O plus? That's a lot more likely than H2O becoming Cl minus, okay? So we're going to group these two together. All right, so once I have them grouped, step one is to group them in pairs, okay? So I've got one pair here and one pair there, however you want to write it down. And now I'm going to take a look and say, hey, to go from the reactant side, which is the before, to the product side, which is after, what had to happen? So in order for HCl to become Cl minus, did it have to gain a hydrogen to get to this point, or did it have to lose a hydrogen or donate a hydrogen to get to this point? Well, obviously HCl compared to Cl minus, it had to donate a hydrogen. So we're going to label this one right here as the acid. I'm just going to do that with the letter A. Okay. And it had to lose a hydrogen, so it had to donate a hydrogen to become this. Okay. Well, if this is the acid, then this has to be what is left. Remember, the conjugates are kind of the after picture. So this guy is going to be the conjugate base, Cb. All right, now we're ready to kind of double check ourselves with the other one. Since this or this had to be the acid and the other one had to be the base, this one should be the base, but let's just take a look at it and make sure. To be the base, remember what has to happen. It has to accept a hydrogen. So H2O goes to H3O plus by gaining one hydrogen. And according to the Bronsted-Lowry definition, a base is a hydrogen or a proton acceptor. So this guy would be the base, which would mean the only thing this could be would be the conjugate acid. All right, so this one had to accept a hydrogen to get here. Okay, so we're going in this direction, looking at this one. We're going in this direction, looking at this one. All right, so let's just do one more to make sure you got it. Okay, the next thing we're going to do is take a look at these two. These two compared to these two, you can see right away which ones are the most similar. Okay, so if we take a look, this one obviously is more like this one than it is this one. And this reactant, H2O, is more like OH negative than it is this one. So step number one, remember, pair them up. Step number two, see what's happening with the hydrogen. So start off with this one. So I've got CH3NH2. I've got CH3NH3. So right here we have 3, and it used to be 2. So in order to go from here to here, what had to happen? That's right, it had to accept a hydrogen. Okay. To get to this point. So remember, if you're a hydrogen or a proton acceptor, you're going to be the base, which means this one had to be the conjugate acid. All right? So based on what we have right now, this should be the acid, but let's follow the hydrogen to see what happens, okay? The H2O becomes OH negative. This has 2 hydrogens, this has only 1. So in order to go from here to here, it had to donate a hydrogen. To get to that point. Therefore, remember, if you're a hydrogen or a proton donor, you're going to be the acid. So then the only thing this could possibly be is the conjugate base. Okay? Remember, the acid, after it loses the hydrogen, becomes the conjugate base. The base, after it accepts a hydrogen, becomes the conjugate acid. All right? So take a minute and do the next one. Stop the video and then come back in just a second and see what you got. All right, so do this one on your own. Take about a minute, stop the video and come back. And I'm going to go ahead and pair these up while you're gone. All right, welcome back. So take a look at what happens. I've got H2SO4 and HSO4. Okay, so in other words, to go from H2 to H, I had to donate a hydrogen, so that means this one would have to be the acid, and this one would have to be the conjugate base. All right, makes sense? Now check the other one, okay? Check the other one. Make sure this one should be the base, but in order to be the base, remember, I had to accept a hydrogen. So we have 1 hydrogen here, but I have 2 here. So if I accept a hydrogen, that means you're right, this would be the base, and this would be the conjugate acid. And guys, that's all there is to it. Remember, this model, okay, of conjugates only applies to Bronsted-Lowry acids and bases, okay? Whole different ball game when we're talking about the Arrhenius model. Thank you, and I appreciate it. And remember, it works if you work it.